Hello everyone, today I will be showing you how to create multiple parts in Solidworks and assemble them together. So I will be using a little rocket, and I created this rocket based off of the Mercury Redstone Rocket. Here's a picture of the real one right here. So this is a two-stage launch rocket. The crew capsule is up here, right in the top over here. Let's zoom in a little bit. So the crew location is right here, and everything below it is the rocket and the fuel that's used to power this and whatnot. So this actually is a two-stage, or I guess a one-stage. So I have it already done in SolidWorks and assembled together, but I'm gonna walk y'all through how I did this. So as you can see, I did create two stages here. The first stage is the lower half, or stage 1 base, is what I named it, and second stage is the crew part up here on the top. So let's go through the base. Okay, so some of y'all might be new to SolidWorks. I apologize, I do not have Inventor, and I don't have enough space on my laptop for Inventor, so I will be using SolidWorks. I have been using SolidWorks for quite some time. So first off, I first created the base of this fuselage. It is a simple cylinder that I extruded out from a circle. So I extruded, and these dimensions are all in inches, and I kind of just made up some dimensions. It's not to scale, by all means, it's not to scale, but I kind of made some reasonable dimensions. I am also designing this for 3D printing at the same time. So I can get into that a little bit later. But so the first part is to make the base fuselage here. So I took a circle, made it 1.5 inches diameter, and I extruded both ways. So let me show you all that. I used what's called a mid-plane extrusion, and you can see that right here, mid-plane. And what mid-plane does is it takes this total thickness that you want to extrude, or total depth for the extrusion, and extrudes it out evenly on both sides of the plane that you drew your sketch on. So I created the base fuselage here. So next step would be to kind of get some lines down for just basically like center lines of my total body here, just to kind of keep things lined up and straight, and you'll see why in a little bit. So I created a sketch with this center line going down here, and I also created a sketch with these two lines going here. Where all these three lines intersect is the origin of this particular part. So I did that to kind of get my axes down, my X, Y, and Z, and I can visualize where everything is. So the next part is the fins here. So I created these fins here for the end of the rocket, and we can go back to our picture here. And as y'all can see, there's fins in this lower half right here. So I did it accordingly and made some basic fins here. So let's go back to our here. So I made these fins. First off, I made two in this sketch, and what I did was I first created this triangle here. Well, it's actually a trapezoid, but let me get into that in a little bit. But I created this first shape here, and then I simply mirrored it along this line here to the other side. And I used this mirror entities function right here. So when you're designing CAD work, it's very important to kind of make it easier on yourself by if something's congruent or symmetric, then it's easy to just mirror it. And I utilize that a lot here. Also, patterning. If you pattern something, I'll get into that in a little bit here, actually. And yeah, it just makes it easier when you're designing stuff. So it's very important to keep that in mind. So I had to actually modify this triangle first, and I'm zooming in, and I originally had it end at this point and go straight down along the base of this fuselage, is what I'm going to call this. But the thing is when I create a 3D shape out of this, I extruded it and it made it flat. So I did not take into account this curvature of the fuselage here. So when I did first initially extrude it, it was only attached at one, I guess, one line. As you can see right here, this one point is both on this line and on the fuselage edge. So I had to extend it into the model a little bit, and that's why it's technically a trapezoid shape that I extruded. That was done with just a basic extrude boss / base function right here. And I believe most CAD packages call it the same thing, or extrude base or extrude shape. They're all more or less the same. If you know one CAD package, you know basically all of them. They all do the same, more or less the same thing. It's just takes a little bit of, okay, where is everything located? Where are my functions at? Like where's my sketching tools? Where's my other kind of 3D geometry tools, stuff like that. So like I said, that's why I'm going to show y'all this in Solidworks. I know y'all are more than likely using Inventor, but again, everything carries over. So anyways, so that's why I decided to modify the fin shape a little bit and extrude it into the fuselage. And I also extruded both sides at the same time. Again, that made it easier on myself. And y'all can, in fact, see that extra little bit I gave here. This little line right here is the width of that extra little bit of material I gave it. So, you might ask, what's next? We need 4 fins instead of 2. Since if we go back to our base picture here, it looks like there's at least 3 fins. And from this picture, it looks like there's more than likely 4. There's just one we can't see on the backside. So that's why I decided to go with 4 fins. So let's head back over here. So you might ask, how do I do this? Well, that's easy. Like I mentioned before, remember to try to pattern things. So if I just scroll down to the next one here, I used a circular pattern. And y'all can see all this information here, pattern type circular, and it used this base fins here as the template. So that pattern right here is under linear pattern. In SolidWorks, it's linear pattern and circular pattern are in the same little thing here. So it's very easy to do. So I created one copy of it since I already had 2 fins. Let me show you all that right here. So as you can see, the number of instances, which is just the number of copies, is 2. That it counts 1 for the original. So if I were to change this to 1, I can't change it because you need to have the 1 in there. So you can't. It's not going to do any good to pattern something if you just want the original. So, so that's why I use 2 instead of 4 or something like that. Just to make it easy on designing and stuff like that. And there we go, 4 fins. And all these have that extra little, it does extrude into the base fuselage a little bit. So that is a plan. Now what's next? Next is I'm going to do the engines. So, but first off, I had to add a plane. And I added this plane at a 45-degree angle to the fins. As y'all can see here, let me just get a more spot on view here. So this line right here, that's our plane 1. And I had to create that. We'll see that why in a second. But as you can see, it's at a 45-degree angle from these fins. So next is I'm going to create the engine. So as you can see, I created one engine here in this little conical shape. And I created that by doing what's called a revolved boss/base. That button is right up here at the top, right next to extruded boss/base in Solidworks. So I decided to do that because you see my sketch right here. Sorry, let me just move a little bit. So when you revolve, or when you want to create a 3D shape by using the revolve boss/base function, you got to remember to draw half the shape and then spin it. You're basically spinning it around a axis or a axis of rotation. And when you spin it, it will create this conical shape because I drew a trapezoid shape. And again, all these dimensions on screen are just I just kind of eyeball these dimensions. It's not to the actual scale of the rocket. So keep that in mind again. But yeah, so I created this half shape, revolve, extruded it around this center axis, and I created a nice little engine. Now, as you can see here, in the same sketch, I did also mirror the other side. Very similar to what I did with the fins. I use this mirror entities right here in the sketch while I am in sketch. As you can see, I'm currently actively editing the sketch, and you can mirror sketch entities. So that's how I did that. I mirrored it around the center axis line, and that's why I created those lines at the beginning in their own sketches, and I'm leaving them there because they act as a reference towards everything else. Especially when you're making cylindrical shaped objects such as rockets or anything that's cylindrical shape. If you make a jar or anything like that, it's very important to have your axes, and you know which ones to revolve around, and you know which ones to mirror across. It's very important when you're designing. So as you can see, I also mirrored the same shape on the other side, and that is reflected in the next operation. So I repeated the same thing. I revolved this sketch around that central axis of it, and I created another engine using the same thing. I could have mirrored this whole shape, but I just wanted to do it in the same sketch. You can do either one. It really doesn't matter, but it's more of whatever you're comfortable with. So the next part, we need 4 rockets, or four I guess exhausts. I tried to find some information on this, but if it was me, I would have four exhausts, or 4 thrusts. So that's why I went with 4, as you can see right here. So let's go back to our Solidworks file here. So I just did the same thing I did with the fins. I circular patterned this engine, both of them actually, and I circular patterned it, and boom, now we have 4 engines. The trick to CAD and doing it very well and very quickly is utilizing mirrors and patterns, and that's how you get everything done very quickly. Also, making sure your dimensions are the same for everything. So, next, let me just hide this plane here. It does get in the way. So next, I wanted to add on the going down from the top of this fuselage. Just get a better view here. I wanted to add the words United States because that is a key thing, I believe, in this rocket. It says United States down the side. So I'm making this to 3D print. So I thought, well, why don't I cut the text into the fuselage, so that when I 3D print it, it will 3D print that way and come out looking nice. So let's head back over here And text is easy to do in SolidWorks. I am more than likely sure it's easy to do in Inventor, a very similar way. Like I said, every CAD package is more or less basically the same. It just determines, how do you do certain operations or where are they at in the user interface. So I wanted to create a text. Well, I needed to offset the text plane or the text drawing plane from the fuselage, and I did that by adding the second plane. And as you can see, it's barely off of the fuselage. It's a little hard to tell, but it is there. It is not sitting on the fuselage. It's just hovering up slightly offset the surface. So that's so now let's get into drawing our text. Now I already extruded this, but I will take you through I will walk you through how to add text. It's a It's a very, very simple thing to do. Let me just hide this plane real quick. So you just use a sketch like you would normally, and let's normal this too. So to add text in SolidWorks, at least, like I said, I'm sure Inventor works the same way. Is you first create a construction line, and it has to be a construction line, because if you were to try to draw a regular line and add text on top of that, SolidWorks, and I'm sure other CAD packages will give you the same type of error. SolidWorks will give you an error stating that it can't extrude a line. A line has no area, so there's no cross-section area for it to extrude to make a 3D shape. So that's why you should use construction lines. And try to use construction lines whenever you don't want like a mishap with a real line or something like that. So that's when construction lines are utilized heavily. So so now you have your line on where you want your text to be. So I'm just going to use this U as an example. So I click this line, it is selected. See how it's highlighted green, changed colors compared to, let's say, this one down here is blue. And on SolidWorks, to add a text is just a simple thing. You click this text right here, and I can type in whatever I want. So as you can, I typed in the word United, and it's putting the text on top of this line. Very similar to when you write on, like, let's say, notebook paper. You write your letters on top of a line to write it on, or like when you sign something, you sign your name on top of the line. So SolidWorks does the same thing, and I'm sure Inventor works the same way. So from here, this I can edit the text using all these. It could be, I can make the text centered on the line, or to the left, or I'm sorry, right or left. Obviously, here's an example. If I do that, then the text, parts of the text is only shown. That's a simple fix. You just extend the line. But obviously, I don't want one word right here, because United States needs to go vertically down the rocket. So that's why I only typed in the letter U. So on SolidWorks, it's easier to edit the text and to make different fonts and stuff if you uncheck this Use Document Font. From here, I can click on Font. And as you can see, we have a plethora of different fonts. I believe it uses the Microsoft fonts that are already on your computer. Obviously, you can add more fonts if you were to add more fonts if you download them from the internet or so. But for this, I just want a basic font. So Century Gothic was the default font, so that's what I use. It helps to make them bold, especially for like 3D printing, or if y'all do any laser cutting type of stuff or engraving. It just helps to make the letters bold, because they have a bigger area or bigger surface area, especially if you're 3D printing. The area that the text takes up will be bigger. So that's why I like to put on this bold. You can use units to designate the height of the letter. I like to use points just because I'm familiar with that while working in, let's say, a word processing software such as Microsoft Word. You use points to change your font. So let's say I want to make the font size 16 points font. So I can click OK and see how it changed it. Now I increased the font size, which increased the letters. Because the word is bigger and the letters are bigger, not all the text can fit on the line. Again, that's simply solved by increasing the length of the line. I will not show you that. That's very simple to do. All you do is just exit out of this text box and extend the line manually. I will not do that because it will throw off everything else in this sketch, just because I have everything already done. So yeah, so if I were to add this text, I could just click check, and it added it. Now I need to undo that because I don't need that text. And that's how you do text in Solidworks. Again, I'm sure Inventor works the same way. Now to do these lines, I did pattern them. I did a linear pattern right here. So let me take you through that. Let's take this line, and I couldn't turn the text to where it will read in a line like this on Solidworks. So I had to break up each text into, or the full word into a letter to do it this way. Because like I mentioned before, the Solidworks will put the text on top of the line, and obviously if you have a vertical line, the text would read sideways. So it just won't work like that in this type of situation. So I had to pattern this line, and of course I wanted them in even spaces, so hence why I patterned. So I click this linear sketch pattern here, and I can have an X direction and a Y direction. So let me just increase the spacing here so you can see. As y'all can see here, it creates this yellow, I guess, pre-line. It gives you a pre, what's the word I'm looking for? A preview. Yes, a preview of whatever you're patterning. So that's more clearly seen in the Y direction because this line is pointing in the same way as the X axis is pointing. So it's parallel. You're not gonna see the individual ones. But it works the same way. So in this Y-axis one down here, direction 2, I'm just going to increase the number of instances, again with that, to 4. And see, it will take the original as the first instance and make 3 copies of it. As you can see here in the preview, this is where the lines would be. And to add those lines, I just click check, and there you go, it added the lines. And of course you can change the spacing between them and everything else. I did that. I made sure that they're all even and everything else. So let's exit this sketch. And all I did was I cut into the fuselage. So let me edit this feature, show y'all. I used what's called the extruded cut. I can't select it right now because I'm editing a function. But it's this extruded cut right here. What that extruded cut does is it takes whatever shape you sketched on a surface or on a plane. It will take that and extrude it out. So you see this preview of this kind of yellow preview here of the letter, and it's going to everything where that material or that sketch is, it's going to cut away all the material and remove it. Hence why it's called extruded cut. It does the exact opposite of extruded base. Extruded base takes that shape and extrudes it out a certain distance and creates material, and it adds material between it. Extruded cut does the same thing, takes that sketch, moves it out a certain distance or depth, and it will remove all material within there. So, hence we have these very nice looking letters on the side of our fuselage of stage 1 of part of our rocket. Now I do the same thing with the second word, states, to get the whole United States on the side of the rocket. Looks very nice. I did not cut too deep into the fuselage, only because I do plan on 3D printing this, and that could create some overhangs, and that's a whole nother issue to get into that I'm not going to go over at this moment, because that does not pertain to the actual CAD part of this, what I'm trying to focus on. So that's why I only extruded, or I only cut into the surface a little bit. Very, very minimal amount. So what's next? Well, I want to somehow connect stage 1 with stage 2 of the rocket. I plan to 3D print both stage 1 and stage 2 separately, and then kind of, tighten them together, and I will go over how to do that. So let's look at our pin connectors. I made some just extruded some basic circles here. As you can see in my sketch here, I did the same thing with the mirror here. So I created a circle here with a specified diameter that I wanted, and I mirrored it across a plane, and I believe that is the right plane, front plane, that I mirrored it across. Yes. So as you can see, this front plane is here, and all I did was mirror the circle to the other side, just to make sure everything's congruent and nice and symmetric. So then I just extruded it out using the extruded boss/base. Extruded it out, in this instance, a 1/4 of an inch. And now I wanted to create a slot that my pins go into and kind of locks in when I twist the other stage 2 on top of this stage 1. Now your connectors don't have to be this complicated. I wanted to do it this way because I felt like it was something within my ability to do, and it's very, very cool looking, and I just really wanted to try it out. But I think a simple pin and hole would work, especially if you're gluing it and you don't plan on taking these parts, or if you don't plan on taking it apart later, then obviously you could create some simple cylinders as pins, and cut a hole in the opposite, the opposite stage 2, which I will show you that as well. You'll see here in a second. So yeah, this you can do the same purpose with that, but I just wanted to be a little fancy here, and I wanted to be able to take those stages apart later. So that's basically it for the stage 1 of this rocket. Let me get a better view here for y'all. Basically done with stage 1. Everything left is just some fillets that I'm using on the bottom here and around these pins. All that does is just helps with the 3D printing aspect of this. So since all of this is technically overhang on 3D printing, it might tend to mess up a little bit, so I wanted to add these fillets around here to help support everything. And I don't want to get too much into that because I could give you a lot of information on that. But I just want to mention that. That's why you see these fillet 1 and fillet 2 is on the top over here by these pins. Now fillet 2, I wanted to, again, since I'm 3D printing this, I wanted to help support this top shape up here, so that 1, it doesn't break off, and 2, it will kind of make it more stronger, a little bit more sturdy. So that's why those are there. And that I guess that's about it for stage 1. Let's get a final view here of stage 1 in here. So let me save this. Okay, so now we can move on to stage 2. So I decided to do this one a little different. As with stage 1, I first started with a simple circle that I extruded in 2 directions to a total of 8 inches. Again, these are arbitrary dimensions. It's not to scale, and I didn't make anything to scale here. I just kind of used that rocket as a base and kind of came up with them on the fly. But anyways, I did do this one a little bit different. Since this is a complicated shape here, we have we have this big diameter of circle down here, and then it tapers into a smaller diameter, and then it tapers again, and then it goes to another smaller diameter, and then at the top is a little antenna. To simplify things, I just created a simple basic cylinder up here for that part. So let's have a look at our model picture here. So this stage 1 is down here with the United States down here. And it actually splits right here. And this whole top area is stage 2. Now I didn't want to draw all these little cross beams here. That would not be good for 3D printing. That's why I just kind of made it just a straight solid piece. So, but as you can see though, it does taper, and I think it tapers a little bit more, and then goes straight, and then here's that little pointed antenna at the top up here. So as you can see, this shape is a little bit more complex to do. I mean, you have these tapers here, and it's not a constant, constant cylindrical shape such as down here. Well, how, you might ask, how did I alleviate that, or how did I simplify it? Remember, you always want to simplify things when you're trying to work with CAD and you're trying to create a 3D CAD model. Simplification helps out drastically. It helps speed things up, makes it easier on you, so you're not spending, let's say 4 hours on the CAD trying to do one CAD part. Instead, it's going to take, let's say, 3 or 2 hours. So it's a bit, we overall have a bit more complicated shape. So how would I do that? Well, that's simple. If you remember how we created the engine part of the rocket, let me show that down here. If you remember how we created these little engines here on the lower half, we did what's called a revolved boss/base. So I do the same concept. Same concept with the stage 2. Since that, again, that's more complicated shape. So that is oh, that's all the bottom. I'll get to that in a second, but let me show you all this right here. And make it normal too. So as you can see here, I created half the shape right here. And also, as you can see, I have this center line right here going straight down. That's my axis of revolution. And I created this shape. Again, these are arbitrary dimensions. I did not make this to scale. But anyways, I drew half the shape here, half the cross section. And then I revolved it around an axis. Makes it very easy to draw this. Instead of having to, let's say, extrude a cylinder out or extrude a circle to create a cylinder for here, and then, maybe lofting material here. A loft is when you have two parallel shapes and you want to add material between them. The shapes don't necessarily have to be the same size. I don't want to use that function because it's a bit difficult to do that. That's a more advanced type of function, but to create this shape easily, again, I just revolved, extruded it. Very simple. Creates this nice conical shape, but it has varying diameters of, cylindrical diameters. And that was basically it for the stage 2. It's very simple. All of this down here is my, my connector, pin connector slots and everything. So, which I will get into right now. So I mentioned how, I wanted the pin connectors to, slide in and turn. So here it is. This, the top of that pin connector slides in here, and you twist this stage 2 onto stage 1, and it should lock in here. Or at least, get stuck right here, and at least you can't pull it straight out. That was the design of this, so that was my kind of what I was trying to do here. What I was trying to implement. And I did that with a series of, first off, cut extrudes. As you can see, I cut extrude a slot into it, right here. I'm sorry, it was a circle. I extruded this circle here. Let me take you through step by step. So as you can see here, I just did a simple cut extrude right here, and just cut a circle in. Now I cut that circle in the depth that my pin goes, and all these dimensions I already came up with. So I created the pins first, and then I created these holes. So next, what I did was I drew a slot. I drew a slot here. As you can see, let me just make this normal too. I drew a slot here that goes into this cut and has this slot shape. So for when I twist the two stages together, they kind of, there's a path for the pin to follow. And as you can see, I drew the sketch on this bottom face of stage 1, or I'm sorry, stage 2. And I cut down a certain distance that, the cap of that pin goes up to. And it will become clear when I get to the assembly and show you all the inner workings of this. It will become way more clear. Very easy to see there. So I created these slots. I also just mirrored this again. Actually, no, I actually circular patterned this. Right here, I use this circular pattern feature. And that's how I was able to flip this 180 degrees at the same dimensions and same angle and everything. So I did have this going 60 degrees. The pin should turn, the pin should turn 60 degrees. So on to the next one. Actually, hold on. Okay, it did exit the sketch. Yes. Okay, so the next step that I did was I created a pin slot. I had to create the head of the pin so that the head of a slot for the head of the pin, so that the head of the pin can move while still being constrained inside this slot here. So that's actually a very ingenious thing I thought of, where I just got a rectangle here that was the same length of the diameter of the head of that pin, and I cut revolved it. The cut revolve feature works exactly the same as the revolved boss/base feature, except this time again the only difference is you're cutting material away. So I did that to again make it easy on myself, and I mirrored the sketch and I only cut away 60 degrees because that's the extent of my pin slot. So I want the stages to rotate 60 degrees and they lock in again. So again, easy way to do it. Create some rectangles and revolve cut. So what's next? This edge here, that's the pin will not fit there, will not sit. So how did I alleviate that issue? Well, let's drop down again here. And as you can see, I again cut revolved. Same thing. I did a simple rectangle with an axis line right here, a construction line as the axis of revolution for this cut, and I revolved it around 360 degrees, and I created a slot for the pin. Now we can better see that if I were to create a section view here. As you can see, this see how the pin would slide in and kind of be constrained inside the slot? That's why I did that. And then I believe I did the same on the other side. Yes. I did the exact same thing on the other side. And so that's it for stage 2. Stage 2 is relatively simple. The only thing complicated that I did was these pin slots. Again, you can achieve the same thing if you just make some simple cylinders stick out of stage 1 and slide into just basic holes on stage 2. Obviously, the holes need to be the same size or slightly larger than the pins. If you're going to 3D print it, that would be just dialed in with your 3D printer. There are so many different 3D printers out there. Each one has a different clearance for moving parts. So I already know my clearance on the 3D printer that I will be using, so that's why I adjusted accordingly on my end. So that's basically it. This fillet right here is on the inside because I did fillet my pin, so hopefully we can get a good cross section of that pin. As you can see here, that's looks exactly like the pin shape that I made in stage 1. And again, we can see that reflected in the assembly here. And that's stage 2. Let me just get a better view of it here. Again, very simple. Remember the revolve extrude, very useful, very, very useful. So let me save this. And now let's jump into the assembly you have. Sorry, Solidworks has to rebuild the assemblies if you have them opened up, and to reflect any changes you made in the parts. Since I saved each part again, I didn't really change anything, I just resaved them. Solidworks still needs to rebuild the assembly. And here's the fully assembled rocket stage. Both stages are here, present. We have stage 1, the base, in green here. And we have stage 2, the crew area. Since again, this is a very simple rocket. This rocket was produced back in the 1950s. So it's a very early rocket. It only had 1 or 2 stages. So, so when we go into an assembly, we actually I could probably scroll this up. Actually, I can't. But anyways, when you open an assembly, we automatically go to insert components. So I will make a second rocket here, just to show you all this part, since this is a very important part. I actually want to do the base first. So as you can see, I can drag my mouse and it can move anywhere. Just sorry, my computer's a little laggy at the moment. So I can click here and it drops it into the, I guess, build frame or build space. We can call it a build space. So it dropped it into the build space here. And yeah, it's already orientated the way that I want it because, again, I built this vertically since a rocket is vertical. As you can see, you have my pin connectors right here. So now let me go ahead and insert another component. And let's insert stage 2. So I want to insert about right here. And as you can see, it's not on the rocket or anything. If I were to click and drag it to get here, it might be a little off. As you can see, it's very hard to move things, or you may think that things are lined up, but in fact it could be way over here or something like that. So when you want to make sure that these are lined up, you use what's called mates, and I'm pretty sure Inventor assemblies work the same way. So what a mate is it tells the software, okay, this face, I'm sorry, where is it? It tells, you can select a face, edge, line, or point, and it tells where that is mated to, or where it's confined. It helps define the whole space and objects in the space. So let's make this. But first, we need to make sure that this stage 1 is fixed. We don't want Solidworks to automatically move this, so we can just right-click on this design tree here and click Fix. As you can see, this little F popped up. That means I cannot move it. As you can see, Solidworks gives me the selected component is fixed. It cannot be moved. So that's how you know something's fixed. So that means when I go to make things, Solidworks is going to automatically move some stuff around, and you'll see that in a second. So it's going to automatically move some stuff around, and it might throw things off. So that's why if you don't want something to move, or if it's already in the correct position, and you want to make sure it doesn't move, you can always fix components and unfix them, or in Solidworks cases is called float. So let's get into the mates here. So I clicked on mate. So now I can select either a face, edge, line, or point on one object and select it on another object. And SolidWorks will automatically move the first object to the second one in the correct mating position. So let's go ahead and mate this center line here to get things straight. As you can see, SolidWorks gives this kind of see-through view so that I can select, let's say, some hidden lines in here without turning anything. It's very useful if you have multiple objects like on top of each other, which we'll see here in a second. So I want to first make sure these stages are concentric. So that's, again, a great use of this center line that I drew. And I just clicked it here. As you can see, SolidWorks just automatically moved it, but it moved it way further down, which is okay at the moment. As you can see, it's way down here. We don't want that, but we can always move it right now. See how it's only constrained on that line. Since it's a line constrained to another line, everything will be concentric. So let's just zoom in a little bit here. As you can see, it has not moved. It's still concentric with the stage one. And I can just move it up here. Now you can stop and kind of move it here and, you know, zoom in and say, oh, it's connected. But it's not really, because you can move it. It's not fully defined. Or, you know, it's not constrained. Fully constrained to what you want. And you can even move it this way, and it's even, see how you get this like kind of weird kind of material, different color material, stripe material here. That means it's phasing into the other object. So we don't want that either. So I'm just going to keep that right there. So you might ask, well, what do we do now? We can constrain, we have constrained I believe it's the X and Z direction. As you can see, my little origin triad here. You can see this the X direction, Y, and Z. So we constrained it in the X direction. It's not going to move off that line. So it can only move in this Y direction and Z direction and rotate. As you can see, I am rotating the stage 1 here. I'm sorry, stage 2. But I can move it back and forth, and I don't want that. You know, I want it to be in these pins. So that's a simple, you just add another mate. So we're going to do that. So last time I made this line to this line. Another common mate is face to face. So I'm going to select the underside of the face here. As you can see, it's did select the face. And I'm going to select the top face of here. Now SolidWorks is going to constrain those faces together. That means that they're going to be coincident and touching. I'll just click check. And get out of this menu real quick. As you can see, I can't pull it up. I can rotate it. But I can't pull up on it. I can't increase its, I can't, you know, change the Y direction. I can only rotate it about the Y. That's it. So that makes it very useful to when you're putting assemblies together. So keep that in mind. Now, to show you, I can actually the useful feature of this made is I can just select. Let's just select here. So this would be a great view of the pins locking feature here that I created. Now I could make these pins here. Oops. I can't make them, but I'm not going to do that. So, what I will show you here, you know, it will go in and slide and then stop. And that's how I created my 2 stages to fit together. So if the pin head will slide in the slot hole, and then we can rotate them and twist them together, and they will stop at 160 degrees as finished. This idea, this kind of mechanism is used a lot more extensively than you think. If you tinker with machines and stuff and you take things apart, this is a very common kind of like connector, especially twist connector. Um, but yeah, so this is a completed rocket model, fully assembled, and as you can see, it's right next to my other one that I assembled before. Fully assembled. This looks great to me. It's a great representation of this rocket here, and it is the Redstone. Mercury Redstone launch vehicle rocket. So it was used back in the 1950s. Again, so it's a very old rocket, but very simple to do. Doesn't take that long to do. Remember some of the tips that I did show, such as like revolve base, revolve cut, some extra tips there. And yeah, I hope y'all enjoyed this little short tutorial on creating something like this, and a real quick tutorial on the assembly part. Again, I apologize if you aren't using Inventor or Fusion 360, the CAD software. So things might be in a little different location on your end. But again, if you learn one CAD software, you can learn all of them. And they all basically function the same way. It's just where's everything at? Where's all your different operations up here or stuff like that. So I hope this was very educational and very good tutorial on this. And I will see you next time. Have a good day.